Important dates you need to know. Next Friday, third 9 weeks exam. Okay, it's happening in this class that will replace your lowest test grade up to this point this semester. Next Monday, last day for any late work that you need to get turned in to me. Okay, so if there is still stuff you're missing that you have not turned in, okay, please get it to me by next Monday. Signing your course forms, I will start that tomorrow. So don't have them right now. I don't want them right now. I will start signing them off tomorrow. Okay? Sound good? Yes. Y'all will either go to ATM or you will go to pre-cal are your options for this class. ATM is in between Algebra 2 and pre-cal pretty much. So if you have gotten a C or D or F in Algebra 2, then I will not recommend that blah blah blah. I will not recommend that you go to pre-cal. Even low B's, I would not recommend go to pre-cal. Pre-cal, I'm going to recommend for A's and the higher B's. And it also depends on work ethic and all that goodness. So, because pre-cal's hard. Let's be real, okay? Pre-cal is there's work into it. There's a lot of work into it. So it is just a harder class. ATM is still a fourth year class. It's a mix of Algebra 2 and Geometry together. Is what it is. Okay? Yes. AP Stat is a case by case situation. So if that's something you want to do, then we'll have that conversation and we can look at stuff and decide together if that's something that you would want to do. But you can't do that like instead of pre-cal. I don't think. I think you have to do it with it. I will double check. I will ask Ms. Sapp today if you have to do both or if you could just do the AP Stat instead of the pre-cal. I'll ask her and see what she says. Okay. Hey. Would you recommend? I don't do anything with dual enrollment. That's not my forte at all. I don't know. I would recommend staying here because if you stay here, we have jobs. So the more people who dual enroll, the less classes we have here, the less teachers they need. So I like my job. All right. So I would have a biased answer to your question. I would go to guidance. Okay. We are moving on. So I did decide no quiz this week. Instead, we are testing on Friday overall the probability. Today we're doing conditional probability. And no, you don't have homework because I forgot to print it. So you're welcome. Yay. But you will have homework tomorrow. Maybe double. Maybe I'll print tonight's homework and give it to you tomorrow. I know, right? Okay, so conditional events. Let's look at what that might be. So we have this dice that we already know has 12 sides. If event A is rolling an even number, we know 6 out of those 12 are even. If event B is rolling a number bigger than 8, we know 4 out of those 12 are bigger than 8. Probability of rolling an even number greater than 8. Well, there's only 2 numbers, right? That's only a 10 and a 12. So only 2 numbers that are even and bigger than 8. That would be the 2 out of the 12. So notice the sample size for all of these was the entire dice, correct? Today it's going to change. My sample size is going to be altered a little bit. So probability of an even number is 0.5. Probability of getting a number bigger than 8 is 0.3. Probability of getting an even number that is greater than 8 is 0.16. All right, we good? What if you roll a number greater than 8? What's the probability that it's an even number? Notice my sample size has changed. I don't want to look at every single number. I want to look at just numbers bigger than 8. So if I already know that piece of it, what's the probability that it's an even number? Okay, well, how many numbers were bigger than 8 on the dice? There were 4. How many of those are even? 2. So now it's going to be 2 out of 4, or 1/2. So my conditions have changed. If you roll an even number, what's the probability that it's greater than 8? Okay, so now my sample size has changed. How many even numbers were there? 6. How many of those are greater than 8? 2. So now it's 2 out of that 6, which is 0.3. Okay? Those were examples of conditional probability. That's your fill in the blank. Those were examples of conditional probability. Okay? Because we are looking at a specific subgroup. We're not looking at the entire population anymore. Okay? There is an equation that goes with it. So in that blank spot in the middle of your notes, okay, if I know a piece of my information that is given to us. So if I want to know the probability of event A if I'm given event B already. So what's the chances of an even number if I'm given that it has to be bigger than 8? You already know part of it. So to do that, you're still going to multiply your pieces together, okay, by doing that and. So probability of A and B, but you're going to divide the given piece out. Okay. So remember, this is red. What's the probability of A given my B condition? And you always divide out what you have been given. All right. We can also use this for determining if something is independent or not. Okay. So remember, you don't have to write this down. This is just a remember thing. Independent means one outcome does not affect the other. Okay. Mathematically and equation-wise, it's if. So if I have the probability, what's the probability of A given B? If all of this goes back to equaling my probability of event A, if that happens, then they are independent of each other. Because dividing out the condition did not affect my original probability. So if no effect is made, if it's equal back to our original, then it is independent, or vice versa. So what's in the white part is what goes into that blank square, if you can. Or on this square on the side, excuse me. So this shows that there is no effect. So this is the mathematical proof that one event does not affect the other. We're gonna go back into our Harry Potter stuff here in a minute. Okay. It's gonna be easier to see with some examples for us. Give you about 10 more seconds to write this stuff down. And Noah, you did that quiz, right? You did that one? Okay. So I just need Alex to do that quiz. All right. Okay, so logically, is rolling an even number and a number greater than 8, are they independent? If I'm rolling a dice. If I roll an even number, is that going to change the possibility of rolling a number greater than 8? Not going to affect each other. So we know logically, we know it's independent. We already know my answer is no. We're going to prove it with math. Okay? We're going to show the proof. I know you love geometry. Get those proofs in order. So, in order to prove it, I need to prove that doing 1 does not affect. So, what was the probability of rolling a number, an even number that was also greater than 8? What was that probability? What was it? 0.6? Wasn't it, hold on, an even number that's also bigger than 8? Wasn't that 2 out of 12?
Yeah, 0.16.
Yes, so 0.16. Okay. So probability of A given B. So probability of them together. So that was probability of getting an even number. That was also greater than 8. That was 2 over 12, which you said was also 0.167. And the probability of just getting the number bigger than 8 was 4 out of the 12, right? Which is what, 0.3? Okay, so this simplifies to give me 2 over 4. If I divide my fractions, my decimals, the same thing happened. We get 0.5. Okay. Now, remember, if this equals my original probability of A, is 0.5 equal to the probability of getting an even number? Is that true? Yes. So because that is true, that means that they are independent of each other. They're independent pieces. How do we feel about it? Feel okay? Yeah. All right, now we're gonna get into Harry Potter. I know. You'll be okay. All right, moving on. All right, so same information as before. 80% of high school students are fans of Harry Potter. 30% are Twilight fans. 20% are both. Okay? Given that a student is a Harry Potter fan, what is the probability that the student is also a Twilight fan? All right, so how do I set this up? What is given to me? What do I know about the student? No, I don't know that. I know he's a Harry Potter fan, right? Given that he is a Harry Potter fan. So I want to know, what is the probability of Twilight? That's what I don't know. What is the probability of Twilight given I already know he likes Harry? What is the probability of Twilight given that they already like Harry? Okay. So how is that equation going to look when I set it up? Of T and H, yep, divided by the probability of just H. Good. All right, so what is the probability that the student likes them? 20%, so that's 0.2. What's the probability of just Harry? 0.8. So 0.2 divided by 0.8 gives me 0.25. All right. Yep. So there's a 25% chance that if a student already likes Harry Potter, that they will also like Twilight. All right, my next question is asking me the reverse, right? What is the probability that the student likes Harry Potter if they already like Twilight? Okay, so we're switching them. Switching them around. So now probability. What is the probability of Harry Potter given that they already are a fan of Twilight? So how is this one going to be set up? Probability of H and T over the probability of just T. What is the probability of them both? What is the probability of just Twilight? And what is 0.2 divided by 0.3? 0.667. So which one is more likely to happen? Already a Harry Potter fan that also likes Twilight, or already a Twilight fan that also likes Harry Potter? The second one. Already a Twilight that's also going to like Harry. That one is the more probable case that you're going to have. Okay? To be able to determine if one is more likely than the other, a significant difference of 5% has to be shown. Okay, so 0.05 difference. If there's a 5% difference in their chances, that is a significant enough difference to show one is preferred over the other. Yeah. All right, questions on this one? All right. Next question. Are they independent? Okay. So that means when I did the Twilight, wanting to find out Twilight, already knowing Harry Potter, if that's independent, then that should be equal. So if it's independent, that should have also been equal to just Twilight. What is just Twilight? 0.3. So is 0.25 equal to 0.3? No, it is not. That is not going to work out for me. How about the other one, though? Let's see. If this is independent, finding the probability of Harry Potter, knowing it's Twilight, should equal the probability of just Harry Potter. What was the probability of Harry Potter? 0.8. Does 0.667 equal 0.8? No. So because of that, they are not independent. My two events are not independent. Somehow one is affecting the other. All right, we good? Yes? Ready to do some more two-way frequency tables? You like those. Tomorrow, that's all we're doing.
You like those.
I do like those. You like them too.
Deep down, I really think I don't.
I bet you like it better than Venn diagram.
Honestly, no.
No? The Venn diagram? Okay. Alright. Here we go. A survey of students at the Adams School for the Arts revealed that 62% preferred classical music when studying over no music at all. Okay. In addition, 37% indicated they were left-handed. Of those, 14% said they are left-handed but do not prefer classical music. Complete our table. All right, so they gave us some pieces to fill in. 62% of classical music. That's a total of classical music, correct? So I can put a total of 0.62 from my classical row. Next thing I know is that 37% indicated they were left-handed. So that would be the total of all my left-handedness friends. So at the bottom here, I would put 0.37. Then I have one of the crossovers, right? 14% said they are left-handed and they do not prefer classical music. So this box is going to be my 0.14. All right, that's all we need to fill in the rest. I can complete my left-handed column, can't I? Yeah. What should be in the top? 0.23. Okay. 37 minus 14 is 23. Now I can fill in my preferring classical music, right? What's missing there? 0.39. Because 62 minus 23 gives me the 39 that was missing. Okay. It looks like we're in a pickle. Oh, good. What? The whole table has to equal 1. Good job. Yes. The whole thing has to be equal to a probability of 1 because that represents all that were surveyed. Good. So now we can start filling pieces in. I forget which one comes up first. How about the total that's not left-handed? 0.63. How about the total that do not prefer classical music? 0.24. And then how about how many? 0.38. The total of not classical, this one right here, came from 1 minus 0.62, which is the 0.38. 0.24 comes from not left-handed and does not like classical. So 0.38 minus the 0.14 gave me this 0.24. The last one, you can add 0.39 and 0.24 together. Or some of you already told me you did the 1 minus the 0.37. Either way, you get 0.63. All right, so let's start answering some questions. They're going to get fun. All right. Given that a randomly selected student is not left-handed, what is the probability that they prefer classical music? Okay, so we're trying to find the probability of classical music if I already know they are not left-handed. So finding the probability that they like classical music if I already know they are not left-handed. So we're going to find the probability of them together and divide it by the probability of what I know, which is that they are not left-handed. All right, so what is the probability of them together? So classical, not left-handed, is 0.39, right? And the probability of just not left-handed, 0.63. So it becomes 0.39 over 0.63. Which simplifies 0.619. Okay. You say 0.62? Yeah. What's the number after 9? A 4? Then I would not. Is it 0? Well, then I definitely would not. I would leave it as 619. All right, my next one does not give me words. It just gives me an equation to do. So it just says probability of not C given L. Okay? So what's the equation we're going to use to set this one up? What's my first probability? What goes on top of my fraction? Just one, the both of them, what is it? It's both of them. So the probability of them together divided by the probability of just my L. So what's the probability of them both, of the not C and L? Let's see, not C and L gives me 0.14. All right, and the probability of just L, 0.37. Which simplifies to 0.378378. Okay, what did we just find? Okay, so what piece of the information did you know? Okay, so this was the probability given already that a student was left-handed. What is the probability they did not like classical music? That's what the next thing I want you to do. I want you to put it in words. I want you to put in words what we just did. We found the probability that a randomly selected student is left-handed given they don't like classical music. Right? Something different. L, not C. That is something different. I'm sorry, I confused you. This one is a different one. Probability of a randomly selected student is left-handed given that they don't prefer classical music. This is a new one. This is a new one. Okay. All right. Okay. So this was given that they did not like classical. Next question. If a person is left-handed, okay, so we know that they are left-handed. Are they more likely to prefer classical music than someone who is not left-handed? Okay, so I want to compare. I want you to compare the probability of liking classical music or not liking. Nope, that's not true at all. Prefer. Oh my gosh. What's the probability of liking classical music? We are comparing left hand to not left hand. Correct? If a person is left-handed, they are more likely to like classical music than someone who is not left-handed. Okay. So both cases they like classical. We're comparing left hands versus not left hands. Okay. So remember, in order to tell if one is preferred one over the other, what does the difference have to be bigger than? 0.05. So there has to be more than a 5% difference between the two to say, yes, there is a significant preference. All right, so let's find our two pieces. What is the preferred for knowing they are left-handed and they like classical music? We're going to do the two together, divided by what's given to me, which is they are left-handed. What is the probability of them together? So C and L. 0.23, and the probability of just L, 0.37. Which simplifies to about 0.623. Okay, so let's compare that to my other one. Probability of them liking classical music if they are not left-handed. So what's the probability of them together? 0.39. Okay, yep. And probability of just not L? 0.63. So what do we get? 6.619. All right. So what was the probability of just liking classical music just by itself? 0.62, right? Do any of those show a 5% difference when you have a different hand, if you're right or left-handed? No, they're too close to it. Do you agree? Yes. So because the probability of liking classical music is 0.62, there is not a significant statistic. It is not statistically significant. There we go. There's those words. I got this. They were too close. So we could not say that being left or right-handed had a significant impact on liking classical music. Does that make sense? Even the difference of each other was what? 0.004, right? That's a 0.4% difference of just being left-handed versus not left-handed in liking classical music. So it's too close together. Yeah. More than 5%, so 0.05. Apart from the classical music. Yep. So just classical music was 0.62. If being left-handed or not left-handed gave more than a 5% change from that, then that would show a significance. Correct. Yep, the 5% is the same for all of them. We good? One more, right? Asking about if they're independent of each other?
No, they're not.
They're not? You don't think so? Well, I don't know. I don't know. Let's see. Well, we don't really know our sample sizes. You gotta be careful there, right? Like, you're either left-handed or not left-handed. Or people could do both, technically, right? And think about all the genres of music. This is just saying classical or not classical. So you can't really think that way. Alright, so it's asking me, so instead of trying to logically think it out, there's so many different possibilities. They don't give us too many details about it. How can we mathematically prove if they are or are not independent of each other? So none of the stuff on the board right now is going to help me, right? Get rid of all this. All right, so it's talking about left hand and classical music. All right, so probability of being left hand if they like classical music, okay? If that equals the probability of just, nope. If that equals the probability of just left-handedness, that is showing independence, okay? Or if I do the probability of liking classical knowing they're left-handed, if that is equal to the probability of just classical, that is also showing independence. Oop, gave away the answer. Go back. Okay. So what was the probability of being left-handed if I know they like classical? Did we do that already, someone? So L and then C. We did C and then L. Okay. So L and then C. Let's do that one real fast. So the probability of L and C over probability of just C. What's the probability of them together? L and C is 0.23. Probability of just left hand, 0.37. Which equals what? 0.62. 623. Let's just keep it with those two. Does that equal? Make sure I did this right. Yes. Does that equal the probability of just being left-handed? What did I do?
Oh, you divided by the total left-handed.
JK. Okay. That's why. Thank you. Thank you. Yep, I got those mixed up. You're right. 0.23 divided by 0.62. There we go. That gives me 0.37. Does that equal the probability of being left-handed? Yes, it does. So that proves that it is independent. Okay? We can do it the other way, which we did the other way already. What was the probability of liking classical music if we already were left-handed? 0.62. Okay? Does that equal the probability of just liking classical music? Yes, it does. So both ways prove that they are independent of each other. Logically, that makes sense. Logically, it makes sense. Right? Questions? No worksheet because I forgot. I know. But again, to remind you, you have a test this Friday. Your quizzes are not in the grade book. I didn't give you one. I'm not going to. And your last day for late work is next Monday. So if you are missing a worksheet, I want you to say, hey, I need this specific worksheet. We'll look in the bin, or if I can print it, I will. But don't come up to me and ask me what you're missing. That is your responsibility to find out what you're missing.